Genetics Daily. I'm your host, Caitlin Penrose, and today we're going to be talking about supercoiling and its effects on DNA replication. Supercoiling occurs when the DNA double helix is subject to strain by either being overwound or underwound. In other words, the DNA can't compensate for over or under rotating by simply turning the ends of the DNA double helix. This is generally the case when the DNA is circular because there are no free ends. For example, in this bottom picture, the DNA is circular and there are no free ends, so it can't rotate. If the DNA has free ends, then the DNA will just turn at the ends to compensate for any added rotations, which will take it back to the relaxed state. This can be seen in the top picture. There are free ends in this DNA, and so it can rotate at the ends to compensate for extra strain. Positive supercoiling occurs when the DNA double helix is overwound. This means that it will have less than 10 base pairs per turn, and it will be more difficult to separate the two strands. Negative supercoiling occurs when the DNA double helix is underwound. This means that it has greater than 10 base pairs per turn, and it is easy to separate the two strands. We're going to take it over to Wendy for a live example of positive and negative supercoiling. Using these two tubes, I'm going to show you how supercoiling works. When DNA is positively supercoiled, it will wrap in on itself and will overwind. As you can see here, the strands are harder to separate. When DNA becomes negatively supercoiled, it will become underwound and the strands will be easier to separate, as you can see here. Thanks, and back to you, Caitlin. We are going to discuss topoisomerases. Topoisomerases work to either unwind DNA that is overwound or rewind DNA that is underwound. Topoisomerases work by temporarily breaking the nucleotide strands and passing strands through the break and then rejoining. And now we're going to talk to DNA replication on his opinion of supercoiling.
Thanks, Caitlin. I personally favor negative supercoiling because the strands are easier to separate, so I don't have to waste so much energy separating and replicating the strand.
Thank you so much, DNA replication. That's all for today, folks. Thanks for joining us, and we'll see you next time on Genetics Daily.